This precedence network shows the task involved in manufacturing a television at a factory. This question comes from Hazy and Hazy on page 342, question 6. And firstly, we want to list the tasks that need to be completed before task M can begin. So our task M is here. The task that we need to complete before then would be obviously task K. Before task K though, we must do task G. And before task G, we need to do task C. But notice also that task F needs to be fulfilled before we actually do task K, as does task B. So our answer here is going to be B, C, F, G, and K. None of the other tasks will be required to do task M. Now we will need to complete the forward and the backward scan of the network. These nodes need to be divided to show the earliest starting time and the latest starting time. The values here refer to minutes. Each value shows the number of minutes the task requires to complete. The forward scans are done showing the earliest starting time, and this is done in this yellow part of the node. And we'll start at 0 time. Task A will take 5 minutes, task B will take 8 minutes, and task C will take 10 minutes. The starting time of this node will depend on the largest value or on the longest time it'll take to do task D or task E. Task D will take us 10 minutes on top of the 5 minutes, so this will be 15 minutes. And I'll just note it up above. Whereas if task E is done, then it will be 4 minutes on top of 8 minutes, which means that it'll be done in 12 minutes. So that means that task H or I cannot be started until all the tasks are done, and that is the earliest time will be 15 minutes. The same thing applies for this node. We must add 8 and 7 to get 15, or 10 and 8 to get 18. So 18 will be the largest value, or the time that the earliest time we can start the task. To work out the earliest time on this node, we need to take into account that there are 3 tasks that need to be accomplished before we do that. So we try to find the largest value for each task. Working through task H, it will take us 15 plus 6, 21 minutes. Working through task I, it'll take us 15 plus 5, which is 20 minutes. And working through task J, it'll take 18 plus 6, which will be 24 minutes. So we need to choose 24 minutes before we begin task L. This node now requires 2 tasks to be completed, L and M. So 24 plus 11 will give us 35. But if we work through task M, 22 minutes plus 8 will give us 30. So the longest task needs to be put in here, 35. And lastly, we just have task N, and that will finish at 44 minutes. Now for the backward scan, we start with 44 minutes, and we're going to be taking away the time for each task. It'll be good to draw an arrow for each task before we start subtracting these times. Because there's only one arrow joining this node here, we only take away 9 from 44, and that'll be 35. There's only one arrow joining this task, so this will be 35, take away 8, which will be 27. 1 arrow for L, so it'll be 35, take away 11 and be 24. But now we come up to tasks where there are 2 arrows attached. So we're going to take, this time we're going to take the smallest value, not the largest value, but the smallest value that we arrive at. So 24 take away 6 will give us 18, whereas 24 take away 5 will give us 19. And we're going to take the smallest value, which is 18. And we do the same thing for this node over here. 24 take away 6 is also 18. And 27 take away 4 is 23. So we will have 18 here. There are 2 arrows joining this node. So we need to take 4 from 18, which is 14. Or 7 from 18, which is 11. And we take the smallest value, so it'll be 11. Right at the bottom here, 18 take 8 is 10. There's only 1 arrow. And at the top we have 18 take away 10. Now the smallest value to get to the start is through C, and that will be 0 here. And so the minimum completion time for this project is 44 minutes. And the critical part will be the one where the backward scan and the forward scan is exactly the same. 10, 10, 18, 18, 24, 24, and then we head to 35. And finally, by how much can task E be delayed without causing a delay to the whole project? Let's just have a look at task E on its own over here, or bring it down. And what you see here is that this node here has the earliest time of 8 and the latest time of 11, which means that there is a slack of 3 minutes over here. And when we look at this node over here, we find that E can finish either at 15 or at 18. So there is also a slack time of 3 minutes here. In other words, E can be delayed without causing a delay to the project by 6 minutes. 3 and 3. And finally, due to a fault in the machinery, either task I or task J must be delayed by 3 minutes. Which task should be delayed? Explain your answer. Let's start with task J. Let's have a look at task J on its own. Well, we've got 2 critical tasks here surrounding task J. This is a critical task because we've got 18 earliest time and 18 as the latest time. The same thing goes after you've done task J. You've got 24 minutes earliest time and 24 minutes latest time. Obviously, we cannot delay task J. But if we look at task I, we can see that there is a slack time of 3 minutes here, but that refers to task H. Task I actually is shorter, and therefore its slack time will be 3 minutes plus 1, which means that we can delay task I by 4 minutes.